Final question for it's all about vectors. We've been told that the point A has the coordinates 1, 2, minus 3, and coordinates of B are 5, minus 3, 0. Then it says find the equation of the line that passes through A and B, and we know the equation of a line, if it passes through 2 points, we can either use A or B. I'm going to use A plus lambda B minus A. So if I sub it into that equation, I'm going to get 1, 2, minus 3 plus lambda B minus A. So 5 minus 1, 4, minus 3 minus 2 is minus 5, 0 minus 3 is 3. And that's part A. And then part B, they have given us another line, which is 4 minus 4, 3 plus mu 1 minus 2, 2. And they want us to show that A, which is 1, 2, minus 3, lies on this line. And if it does lie on this line, then 4 plus mu, so 4 plus 1 mu, so looking at this bit, the I component, that has to equal 1. And if that equals 1, that means that mu must equal minus 3. And then looking at the J component, so if minus 4 minus 2 mu has to equal 2, then if I take the minus 2 mu over, take the 2 over there, minus 6 divided by, so I get minus 6 is equal to 2 mu, and so this implies that mu is minus 3. And finally, looking at the K component, 3 plus 2 mu has to equal minus 3. So we get 6 is equal to minus 2 mu, which implies that mu is minus 3. And because mu is minus 3 for all three of them, then that point must lie on the line. You should get the same mu value. Part C then says find the degrees, the acute angle between the lines. So let's just do it's in 2D. We're sketching in 2D, but these are 3D lines, so it doesn't really matter how you sketch it. So this is line 1, this is line 2. We know that they both had intersected at point A, so you can label this A if you want. And we're trying to find this angle here. And we know that when we're finding the angle, we need to use A dot B equals mod A mod B cos theta. And theta is the angle in between these two vectors. So what's the equation of line 1? Well, that was 1, 2, minus 3 plus lambda 4 minus 5, 3. And the vector, the line 2 equation was 4 minus 4, 3 plus mu 1 minus 2, 2. And when we're doing finding the angle, remember that the first part of the vector equation of a line only tells you a point on the line. It's the direction vector, which is the bit after the lambda or the mu, that we need to use as our A and B when we're using this formula. So it's going to be 4 minus 5, 3, dotted with 1 minus 2, 2, divided by the magnitude of 4 minus 5, 3, and 1 minus 2, 2. And that's equal to cos theta. When I dot them, 4 times 1 is 4, plus 10, plus 6, divided by the magnitude, so 4 squared 16, plus 25, plus 9, times by the magnitude of B, so that's going to be the square root of 1 plus 4 plus 4. And so at the top, we'll get 20 divided by, that gives me root 50, and that's root 9, so that's just going to be 3. So that's 20 over root 50 is 5 root 2 times by 3. This was root 9, wasn't it? So it's going to be 3. So I'm just going to get 15 root 2 at the bottom. And you can simplify that if you want, so that gives you 4 over 3 root 2. And if we cos inverse this, we should get the answer. I think that gives you 19.5. 19.5 degrees. So that's the acute angle. And in part D, then they said, point C lies on line 2, and it has the coordinates 2, 0, minus 1. So let's put point C here. It doesn't matter, we're drawing 3D vectors on a 2D thing, so it doesn't really matter where we put our different values. So 2, 0, minus 1, and that's coordinates of C. And it said find the shortest distance from C to line 1. So the shortest distance is always going to be the perpendicular distance. So that means this is 90 degrees. And I want to find that dotted line. The easiest way to do this, let me just draw it again. I'm going to call this point X just for referencing. So I'm trying to find out what XC is. But I know that this is 90 degrees. I also know that this angle is 19.47 or 19.5. Right? Make sure you leave that in your calculator, store it. You want to use the exact values. Right? I know that the coordinates of A are 1, 2, minus 3. And I've just been told the coordinates of C are 2, 0, minus 1. Well, I know, just using SOHCAHTOA, I can say that cos of 19.47 ... stored in my calculator is going to be equal to, it's not cos, let's use sine because I'm trying to work out the opposite, which is XC divided by AC. AC being the hypotenuse. But I can work out the length of AC. So that's going to be 2 minus 1 squared plus 0 minus 2 squared plus minus 1 minus minus 3 squared square rooted. And so that's going to be 1 plus 4 square rooted. And that gives me 3. So AC is 3. So now I can say that sine of 19.47 times by 3 is going to equal XC. So if I do sine, and I've left it on my calculator, so sine of that, sine of answer gives me 1/3. Okay, so if I times that by 3, it's going to give me 1. So XC, the distance of that is 1, and so that's the shortest distance.